This video shows you how to analyze insect life table data when females and males have different stages. Creative thinking. If the male and female have different number of stages, for example, first, females go through 5 stages, egg, N1, N2, N3, and adult, while males go through 6 stages, egg, N1, N2, N3, pupa, and adult. Second, females go through 4 stages N1, N2, virgin female and adult, while males go through 5 stages, N1, N2, prepupa, pupa, and adult. Third, females go through 5 stages, egg, larva, protonymph, deutonymph, and female adult, while males go through 4 stages, egg, larva, protonymph, and male adult. How can you analyze them to show the different survival curves? How can you use the TWOSEX program to show the difference in the stage differentiation between male and female? Taking Paracoccus marginatus as an example, it is an important invasive pest. There is obvious sexual dimorphism between males and females, and the number of stages of males and females are different. The female has 5 stages, egg, first instar, second instar, third instar, and adult, while the male has a pupal stage after the third instar. There are in total 6 stages. In the past, we combined the pupal stage with the adult stage. In this way, we could complete the life table analysis. However, the survival rate and life expectancy curves of pupal stage and male stage cannot be separated. In the life table papers, we must report the important population parameters and the major figures to describe the life history characteristics of a population. The important population parameters are fecundity F, prenatal survival rate as A, net reproductive rate as 0, intrinsic rate of increase R, and finite rate of increase lambda. When reporting the population curve, each stage-specific survival rate as xj should be reported first, so that readers can see the sequence of ages and the change in survival rate by age. In the first figure, the age stage-specific survival rates as xj of different stages are shown in order. In this figure, the stage differentiation can be observed. In the second figure, we plot the female age-specific fecundity fxj, age-specific fecundity mx, and age-specific net reproduction rate lxmx. Finally, the curves of life expectancy xj and reproductive value vxj are reported. Because the reproduction value must be calculated using sxj, fxj, and the intrinsic growth rate r, the curves of vxj should not be presented before sxj and lx. Next, we will show you how to prepare your life table data for the TWOSEX program. In general, if you want to use TWOSEX program, females and males must have the same number of life stages. In this file, both female and male has 5 stages. Can you prepare a life table data file with different life stages for female and male individuals? If you prepare a life table data file and in this file females have 5 stages and males have 6 stages to run TWOSEX program will report errors. Here, we use Paracoccus marginatus as an example to illustrate how to analyze and correctly describe the stage differentiation of female and male based on the age stage TWOSEX life table theory. For a proper analysis, we must prepare 3 files, A, B, and C. If no one-type individual died in the pupal stage, you can combine the pupa to male adult because pupa is a part of the life history of male. There are 5 stages for both sexes in file A. Run TWOSEX. Go through steps A1, A2, and A3. You can use this file to get the population parameters R0, R, lambda, T, and fig2. The curves of Lx, Fxy, Y is the female adult, Mx, and Lxmx. You can also get the Sxj curves fig1 and the Xj curves fig3 of egg, N1, N2, N3, and female adults. By using file A, you can also get the correct curves of fig4, the Vxj curves. But the Vxj values of egg, N1, N2, and N3 include and male individuals as it is in all TWOSEX cohorts. The data format of file A, if no one-type individuals die in the pupal stage, we can combine the pupa to male adult for all male individuals. The box on the left shows you the wrong data format. Female has 5 stages, but male has 6 stages. We must change the data format as shown on the right. Since no N-type individual dies in the pupil stage, it is possible to combine the male pupil stage with the adult stage. The male adult duration is actually the sum of the pupil and adult stages. In the second case, if some N-type individuals died in the pupil stage, we must combine the pupa to male adult for all male individuals. Moreover, we have to change N-type individuals died in pupil stage to male, as shown in the left box. The fourth insect died on the second day of its pupil stage. We change this N-type individual to a male survived only 2 days. In this slide, we show you the correct format for both cases. This change will not affect the N3 curve, but SXJ and EXJ curves of pupa and male adults cannot be distinguished. You can get the population parameters as 0, R, lambda, T, and Fig2 from file A. You can also get the SXJ curves Fig1 and EXJ curves Fig3 of egg, N1, N2, N3, and female adults, and VXJ curves. We then prepare a new file B for SXJ and EXJ curves of pupa and male. In this file, all individuals have 6 stages: egg, N1, N2, N3, pupa, adult. All female individuals are changed to N-type died in the egg stage. You can use file B to obtain the SXJ curves and EXJ curves of pupa and male adults. Why do we do this? Rationale. Firstly, because the life expectancy EXJ of pupa and male are independent from female individuals. Assigning females to N-1 will not affect the EXJ of pupa and male adult. Secondly, because SXJ is calculated from N0, this change will not affect the SXJ and EXJ of pupae and male adults. Attention, you must use the same N0, as file A. The correct SXJ and EXJ of pupa and male adult can be obtained from file B. They can be combined with the SXJ and EXJ of egg, N1, N2, N3, and female adult from file A to get the complete SXJ and EXJ curves to show the different stage differentiation between female and male individuals. In order to obtain the correct bootstrap standard errors of the male pupae, the male preadult stage, and the male adults, we need to prepare a file C. You have to insert a hypothetical pupil stage of 3 days for each female. You can analyze file C using A1, A3 to get bootstrap standard errors of the duration of male pupae, male preadults, and male adults, as well as the bootstrap files for the paired bootstrap test. Note well, you must use the same bootstrap samples of file A. Therefore, when analyzing file C, you must select the file number 11 in the folder of file A at step A3. You can always find other ways to analyze and present your data, but you have to check your methods and results carefully to make sure there is no errors. The most important thing is, you have to use the same number of individuals in order to get the correct survival rate curves. In general, when you use TWOSEX to analyze your life table data, many files with the number 15 are generated for you. You can use these files to run timing. They all have the same number of stages for female and male individuals. If you want to show population growth with different stage differentiations between males and females, you must try to master the life table theory, as well as the TWOSEX and timing programs. For the analysis of insect life tables with different numbers of male and female stages, please read this paper. Thank you very much.